Hello everyone, and welcome to our presentation. Today, we're going to explore the fascinating world of chemical reactions. The title of our presentation is Types of Chemical Reactions. We'll also look at the IMERS logo, which represents our organization. Over the next few slides, we'll cover the different types of chemical reactions, how they happen, and why they are important. So let's get started and dive into the basics of chemical reactions together. Now, let's talk about the combination reaction. This type of reaction occurs when two or more reactants come together to form a single product. It's a fundamental concept in chemistry because it shows how simple substances can combine to create something new. The general form of a combination reaction is a plus B yielding ob. This is a straightforward way to represent the process, where two elements or compounds combine. For example, consider the formation of water. When hydrogen gas and oxygen gas react, they combine to produce water. The chemical equation looks like this. 2H2G plus O2G gives 2H2OL. This example highlights how two gases, hydrogen and oxygen, combine to form a liquid, water. It's a classic illustration of a combination reaction in action, and it connects to our overall theme of understanding how different reactions lead to the formation of new substances. Now, let's take a closer look at decomposition reactions. Essentially, this is when a single compound breaks down into two or more simpler substances. Think of it as a complex molecule splitting apart into more manageable pieces. The general form of a decomposition reaction looks like this. Ob breaks down into a plus B. An example to keep in mind is the thermal decomposition of calcium carbonate. When heated, calcium carbonate decomposes into calcium oxide and carbon dioxide gas. This process is important because it helps us understand how compounds can change under different conditions. It also connects to the broader theme of chemical reactions, showing how substances can transform into new forms. Now, let's talk about displacement reactions. In these reactions, a more reactive element actually displaces a less reactive element from its compound. Essentially, the more reactive element kicks out the less reactive one. The general form of this reaction can be written as A plus BC forming AC plus B. For example, if we take iron reacting with copper sulfate solution, the iron will displace the copper. So, iron in solid form reacts with copper sulfate in aqueous solution, resulting in iron sulfate in solution and solid copper being released. This type of reaction highlights the importance of reactivity series because it tells us which elements are capable of displacing others. It's a fundamental concept that helps us understand how metals react and why certain reactions happen while others don't. Remember, the key idea here is that a more reactive element can displace a less reactive one, which is central to understanding many chemical processes in both lab and real-world applications. Let's talk about the double displacement reaction. This type of reaction involves the exchange of ions between two compounds. Essentially, the ions switch places to form two new compounds. It's a bit like a swap meet in chemistry. The general form of this reaction can be written as Ob plus CD, resulting in AD plus CB. For example, when sodium sulfate reacts with barium chloride, the sodium and barium ions swap places. So, sodium sulfate plus barium chloride produce barium sulfate, which is a solid, and sodium chloride, which stays in solution. This reaction is important because it helps us understand how different compounds interact and form new substances, tying into the larger theme of chemical reactivity and reaction types. Now, let's talk about redox reactions. These are special types of reactions where one substance is oxidized, meaning it loses electrons, and another is reduced, meaning it gains electrons. This simultaneous process is fundamental to many chemical processes around us. In general, redox reactions involve a transfer of electrons between substances. While the slide doesn't specify a single general formula, it's important to recognize that these reactions always involve this electron exchange. For a concrete example, consider the reaction between zinc oxide and carbon. When zinc oxide reacts with carbon, zinc ions are reduced to metallic zinc, and carbon is oxidized to carbon monoxide. The reaction looks like this. ZnO plus C yields Zn plus Co. This example highlights how reduction and oxidation happen together. The zinc in zinc oxide is reduced, and the carbon is oxidized. Understanding redox reactions helps us grasp many processes, from corrosion to energy production in batteries. It's a key concept that ties into the broader theme of chemical reactions and how substances transform during these processes.